Hey guys, so a lot of you guys have been asking me about this particular question here. So let's see. We're talking about, we're interested in the thickness of these sheaths. And what do we want to test here? We want to test the null hypothesis that mu is equal to 8.5 versus the alternate that mu is greater than 8.5. They sampled 5 of these sheets and computed an x bar observed of 8.7. Now, to do the test, you first assume that the null hypothesis is true. So, the sampling distribution of x bar, let's say it looks like that, with mu naught being equal to 8.5. This sampling distribution x bar will be normal with a mean of 8.5 and a standard deviation of sigma over root n, which I've calculated to be 0.54, and this is sigma over root n. And we're told to assume that sigma is equal to 1.2. So here we assume that sigma is known and it's equal to 1.2. 1.2 divided by root n gives you 0.54. So one standard deviation above is 9.04. Two standard deviation above is 9.58. Now, here's the problem. There's no alpha given, so you don't know where the critical region is. In order to compute a type 2 error, you need to know the rejection region and the non-rejection region, right? So, if the rejection region were to be somewhere over here, that will be the rejection region because our alternate hypothesis is greater than, it points to the right. The problem is we don't know what this value is. Now what your professor has done here in the solution is he's assumed that the rejection region is to the right of 8.7. Now how he assumed that is beyond me because nothing within the question suggests that that is our critical x bar value. Okay? Now assuming that, let's say the question had been worded in such a way that, you would reject the null hypothesis and accept the alternate should you get an x bar that is greater than 8.7. Under that assumption, then your critical region will be over here, such that all of that would be reject h naught. This will be your type 1 error. This will be your alpha. And again, if that were to be true, then to compute the type 2 error, what I'm going to do is below here I'm going to draw the true distribution of x bar should mu be equal to 9.5. Okay, so if mu truth were to be equal to 9.5, then 9.5 is somewhere over here. Draw a normal distribution on top there, and extending this line, this red line here. When do you fail to reject? You fail to reject when in that region, right? Fail to reject h naught, and beta is this much here, with this value being 8.7 millimeter, and this is the mu truth, which was assumed to be 9.5. So the probability of a type 2 error here, or your beta, is equal to the probability that x bar is less than 8.7 when the true value of mu is equal to 9.5. Now, going along here, then standardizing x bar, we get 8.7 minus 9.5 divided by sigma over root n. Sigma over root n here is 1.2 divided by root 5. And that's going to give you the answer that your professor got here. That right there. Okay. Again, all of this was based on the assumption that your critical region was defined by this red line here, which was 8.7. Now the question is unclear again. Okay. There's nothing here that says that you would reject the null hypothesis in favor of the alternate should you observe an x bar that is greater than 8.7. However, if we assume that the question had been worded in such a way that that is the rejection region, then the methodology here is okay.